everyone, it is Mr. Ranieri here, and we're going to learn how to describe the distribution or the shape of a data set. I have 4 different data sets here, and I have a frequency graph of each of them, a bar graph of each of them, showing how common different responses were, different data values were. And they look different, don't they? They look like they have different shapes, and that means something about the data set. Let's start with this one. The left side looks like a mirror image of the right side. You might be able to guess what this is called. This is called a symmetric distribution. The left side is roughly a mirror image of the right side. Most things that you measure in nature, the length of a leaf, the height of a human, the weight of a human, the length of your finger or your nose, follow a symmetric distribution. For example, here is allegedly the height of US women. There's an average, and you're just as likely to be below the average as you are above the average. It's pretty symmetric. We have a different kind of distribution here where there are 2 separate peaks. So there's a group here that's lower than the average and a group here that's higher than the average, and there's not many between them, right? So the answer is either the data value is very low or it's very high, and there's a trough, a valley between them. There's not so much in the middle. This is called bimodal because there are 2 modes, two popular groups. In this case, low and high are the popular groups. And as an example of a bimodal distribution, we've got, this is an actual screenshot, reviews of the online store Temu. Temu is a bit controversial because some people really like it. You see, there's a group here that give it 5-star reviews, and there's a group here that give it 1-star reviews. So either you get a really good deal and love it, or you get ripped off and you hate it and you give it 1-star reviews, and not so much in the middle. Right? And this means something, this shape, right? It means that either it's low or high, and there's not much in the middle. Either, in this case, you hate it, 1-star review, or you love it, 5-star review, and not much in the middle. Probably risky if you're buying something, because either it's going to be very good or very bad. In this case, we have a negatively skewed distribution. It's called negatively skewed. Skewed means stretched out. And the negative side, so this side here, the lower side, notice that the area below the average, if the average is about here, if the average is about here, let's say, the lower side of the average is really stretched out, and the bit above the average is really compressed. So the negative side, the left side, is stretched out. Most results are at the top end, so most results are at the average or above the average, but there are some rare, very, very low results. So these results here are very rare, there aren't many of them, but they're very, very low. So that's negatively skewed. An example of a negatively skewed distribution might be retirement age, right? So generally people are at this upper end, so retiring, at the usual retirement age, retiring when the government gives you a pension or when you can get your superannuation out. Most people retire then, but some people that make a lot of money early in their life or save a lot of money to retire early, very rare, but you have some that are way down the left here. So these low results, they're very low, but also very rare. There aren't many of them. And this is the opposite, right? So if this is called negatively skewed, then this one is positively skewed. The positive side is stretched out. So notice the positive side here, the bit that's above the average, I reckon the average is probably maybe around here. So the bit that is above the average, above the mean, is really stretched out. And the bit that is below the average is really compressed. There are lots of results there. So most of the results are below the average. Most results are at the low end. And there are some very rare, very high results. As an example, income or wealth follow this. Often when there's a lower limit of 0, for example, you tend to get a lot of results that are clumped at the lower end. So most people are around here, making a reasonable income and wealth, but then you have the occasional outlier way down the top end, because there's no limit to how high you can go, right? So most people are around here, but you have some people that are making lots and lots of money, but they're very, very rare. So these higher results are very, very rare, and the results that are lower are much more common. And these are the four of the main shapes of a distribution that help you look at how results are distributed. All right, get some practice, ask me questions, and I'll see you next time. Bye, everyone.